In this concept, we're going to talk about the surface area of pyramids and cones. So a pyramid is a polyhedron with a polygon base and triangular lateral faces. So again, we have the base, polygonal base, and then we have the height, which is the drop from the center to the vertex to the center of the base. And then we have the slant height, which is from one of the sides of the base and goes on one of the faces up to the vertex. Okay, so the height is different from slant height. Now, finding the lateral area of the pyramid requires finding the perimeter of the base and then multiplying by the slant height. Okay, so it's perimeter of base times the slant height. So then finding the total surface area of the pyramid requires finding the lateral area and then adding the base area, right? So the lateral area is the area of all four faces, right? So this and the back face and then this face, right? So that's the lateral area, and then the base area is the area of this base, right? The bottom base. Okay? Adding these areas together gives us the total surface area of the pyramid. Let's look at an example. Find the surface area of the square pyramid to the right. So the side of the base, or the edge of the base, is 4 units in length. The height of the pyramid is 2. So using this information, we don't have the slant height, but we can find it, right? So looking at one of the faces, one of the lateral faces, right? We could take a right angle triangle with the height, total height of the pyramid, and half of one of the edges, right? And then we have a right angle triangle, and then we can find the slant height, right? So the slant height in this case, let's call it L, is 2 squared plus 4 squared square root. Okay. Oh, sorry. This is the full side of the edge is 4, so 2, right? So we need 2. We need half of the edge, right, which is 2, not 4. And then we can find it using the Pythagorean theorem. 2 squared plus 2 squared is L squared. So then L is the square root of 8, which is 2.8. And then finding the perimeter of the square base, we just multiply the edge by 4. So there's 4 of the edges. Each of them is 4 units in length. The total perimeter is 16 of the base, perimeter of the base. So perimeter times slant height, that's the lateral area, plus base area, which is one of the sides squared, right? One of the edges of the base squared. Any one of these, right? All of them are 4 units in length. This one. Okay? And then we just add the two quantities, and then we get 38.4 square units. So the total surface area of the pyramid is 38.4 units squared. Now we want to look at cones. So a cone is a three-dimensional figure with a circular base and a vertex. In some respects, it's similar to the pyramid in terms of finding surface area, right? Because then it's also the surface area for a cone is also equal to the area of the base and the perimeter, or the lateral area. The lateral area is pi times r times L, L being the slant height. Okay? So the lateral area is the radius of the base times the slant height times pi, because it's circular. Let's look at an example of finding the surface area for a cone. We have this cone with a radius of 5 centimeters and a slant height of 12 centimeters. Find the surface area. So pi times r times L plus pi times r squared. So this is, again, base area, and then this is lateral area. Right? So the total surface area of the cone is 267 square centimeters. Okay, and here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, find the surface area of a square pyramid if the perimeter of the base is 40 and the slant height of the pyramid is 12 centimeters. So the surface area, like we said, is equal to half the perimeter times the slant height plus the base area. Okay, that's for a pyramid, which gives us half times the perimeter, which is 40 centimeters, times the slant height, which is 12, plus the base area is one of the edges or sides of the base squared, right? So if the perimeter of the base is 40 and it's a square, so each edge is 10, right? So 10 squared, right? That gives us the area of the base, right? So half times 40 times 12 plus 10 squared. And then if we evaluate this, we get 340 centimeters squared. Next exercise. Find the surface area of the following pyramid. So we have one edge of the base, and we have the height of the pyramid. But we can just write the same equation, right? So surface area for a pyramid is half times perimeter times slant height plus area of the base, which is equal to half times the perimeter. So the perimeter of the base is 10 times 4, right? Because there's 4 sides, which is 40, times the slant height is, what we could do is we can draw something like this, right? And then draw something like this. Whoops. Not the greatest. I could probably use a ruler, but let's make it work. There we go. So, and then since the whole side is 10, then half of it is 5, right? So this is 5. So 5, so we have a right triangle with 5, 7, and then the slant height L, unknown. But then L is going to be equal to the square root of 5 squared plus 7 squared, right? From the Pythagorean theorem. So we're just going to put that here. And then plus the area of the base, so each edge of the base is 10, and then it's squared. Okay? And then after evaluating all this, we end up with 273.2 units squared. Okay? Next exercise. Find the surface area of a cone if the radius measures 4 inches and the slant height is 12 inches. So for a cone, the surface area is equal to pi r L plus pi r squared, which is equal to pi times 4, the radius, times L, which is the slant height, plus pi times 4, the radius squared. And after evaluating, we get 201 inches squared. Last exercise. Find the surface area of a cone if the radius measures 5 centimeters and the height of the cone measures 7 centimeters. We write the same formula again for surface area of a cone, pi RL, plus pi r squared, which is equal to pi times r. The radius is 5, but we have the height of the cone, not the slant height. But again, it's very similar to the pyramid, right, where the slant height is like the hypotenuse in a right-angled triangle, right? So if this is the cone, right, this is the cone, so the radius is 5, the height of the cone is 7, so the slant height L is essentially square root of 5 squared plus 7 squared, right? So 5 squared plus 7 squared. Right? The radius is 5, which is also the base of the triangle. The height is 7, which is also the height of the triangle. Okay, this is the slant height plus pi times r, which is 5 squared. That's equal to 214.5 centimeters squared. Okay? And this is it for this concept. See you in the next video.